So yeah, this is week 5. Today we're going to be talking about language fundamentals of JavaScript. And my name is Amanda. I am a senior software engineer at a company called Autodesk. I worked for a startup that was acquired by Autodesk, and I mainly work on construction software. And I use JavaScript every single day. I think I have in every software engineering job that I've ever had. So it's a very useful tool to know. So I had an icebreaker. I guess it's our second icebreaker, but that's okay. We'll break the ice a little more. What is your favorite, or what has been your favorite comfort food in quarantine? If you could share in the chat. Ooh, spicy chicken ramen, noodles, soup dumplings. Yeah, ice cream is very easy. Oh, chicken with mole, that sounds good. Kit Kat, mac and cheese, fried chicken. I like all of these chocolate chip cookies. Yeah, I'm making myself hungry now by reading these. Brioche, that's fancy. Chocolate chip cake, cool. Yeah, I guess mac and cheese has probably been my favorite this quarantine. It's just really easy and yeah. So as a quick agenda of where we're going to go, I'm going to talk a little bit about the history of JavaScript because I think it's relevant to some of the things that you learn when you get into the language. I'm going to talk about primitive data types, and I'm also going to talk about arrays and objects. And then I'm going to get into the control flow, which is like while and for loops, things like that. And we're going to introduce functions, which I think they will also talk about more next week. And probably for most lessons involving JavaScript. So to talk about history, JavaScript as it is today is really the powerhouse of the web as we know it. It's kind of an interesting thought exercise to consider what the world would be like if we didn't have this language where you can go into any major web browser like Chrome, Internet Explorer, Firefox, anything, and be able to run JavaScript right there. It would be a lot less user-friendly if you had to learn something specific for every single browser that you're using. So it does some pretty heavy lifting, and it's very nice as a programmer to be able to use this one standardized way to interact with websites. So JavaScript is also everywhere. It's being used in more and more contexts every single day, really. Some of the ones that you might have heard of, React and React Native. React Native makes it possible to develop mobile applications using JavaScript. Electron makes it possible to write desktop applications using JavaScript. Angular and Vue are both popular front-end frameworks, and Node is used to do server-side programming in JavaScript. So that means that if you work at a company like mine, where you're doing both some back-end and front-end development, you can do back-end development in Node using JavaScript, and then switch over to the front end and continue using JavaScript, which is really nice to not have to like switch contexts between those two. So it's pretty incredible, all of the different ways that we use JavaScript today. I kind of said this, but it's server and client side capable, meaning that you can like have an API that's powered by Node, and you write in JavaScript. And then on the client side, you have your CSS, your HTML, and also your JavaScript powering that front-end dynamic code. It is the most common programming language kind of by far. It's used by 67.8% of developers, which is due to a large part because it is the default language of the web, and it's used in so many other up-and-coming frameworks like React and Vue and all of those good things. And it's backwards compatible across 25 years. So since its inception, which is extremely impressive and also leads to some of the weird behavior that you might see if you use JavaScript frequently. We're going to talk about that a little bit. A lot of it has to do with data types and how they're compared. You might see people make fun of JavaScript because sometimes it does things that truly like make you throw your hands up in the air and wonder what's going on. But a lot of that is because it has to maintain backwards compatibility across so many years, which is really an incredible feat that it's able to do. So that partly is why JavaScript is sometimes called the world's most misunderstood programming language, which I think is an apt title. You see kind of a lot of hate about some of the things about JavaScript, and then also obviously a lot of love, which is reflected in all of the different frameworks that are invented. It feels like every year there's a new up and coming one. So JavaScript, a little bit of history, was created in 1995. It was written by a developer who worked for Netscape called Brandon Ike. He wrote it in just 10 days, which is pretty incredible. The name JavaScript comes from Netscape. So Netscape created this language, and they had support for Java applets, which were very popular at the time. So that's partly where it came from. Also, Java it still is an extremely popular programming language. So they called it JavaScript partly to capitalize on that as kind of a marketing technique, which I guess, depending on the way you look at it, kind of worked because JavaScript is extremely popular today. But also it's pretty broadly recognized that JavaScript has nothing to do with Java. It's just kind of like a weird quirk that it's named that. Backwards compatibility we've talked about. It's the only runtime language of the web. And that means that in order to prevent introducing problems every single time there's a new version of JavaScript, they make every version backwards compatible. So if you can imagine what a hassle it would be if every time they release a new JavaScript version, every single browser has to adapt to run on that version, and then every previous version breaks, that would make using the internet a lot less user-friendly. So for that reason, they make it backwards compatible. And it's used in every modern major web browser that you can think of. So we talked a little bit about history, just wanted to briefly touch on that. Next, we're going to go into data types. We'll talk about arrays and objects, like I said, and then we'll do control flow and functions. Does anyone have questions before I go any further? None so far. All right, cool. So data types in JavaScript are dynamic, sometimes called weak, which basically means that the rules are a little bit looser. So in a language like C, for example, when you're writing code, you'll find yourself explicitly writing out what is a string, what is an integer. In JavaScript, you'll just declare those variables and the language will figure out what type it is based on what you're assigning, which leads to some weird behavior that we'll talk about in a minute. So JavaScript also does something called type coercion, which is basically it reads a variable, makes kind of its best guess on what type is there, and then based on that assigns a type to what you're looking at. So this can happen in a couple of ways. It can happen explicitly. For example, if I were to write a string like this and cast this number 1, 2, 3 to a string, that's explicit type coercion. But it can also happen implicitly. Like in this example, it looks like adding up. I have the number 1, 2, 3, and then the addition sign, and then I'm adding an empty string. And when that happens, JavaScript will do implicit type coercion. So it'll say, okay, you're attempting to add or concatenate a string to this number, and it'll convert that number to a string. So how exactly does that look? We're going to try this out in a REPL. And again, if you have REPL, you can kind of follow along and try these examples out. But if you don't, that's okay. I'm going to show them to you as well. It's just kind of an easy way to get something up and running quickly if you want to test something about a language. So I'm going to show you some type coercion. So here we have a bunch of numbers that we're adding up, and then at the very end, we're adding a string. So JavaScript is going to read this as us attempting to concatenate a string. So I guess first, to show you what like a basic string concatenation looks like, it would look something like this. Let me comment out this one. So if I run this, I am going to get hello world for this first one. I'm not sure why it logged that because I commented that out. Do I have a log statement missing here? Anyway, So yeah, so it's concatenating hello and world, and we get a string here at the top. And then next, we're going to look at what happens if we attempt to concatenate a bunch of numbers with a string. So I'm going to hide that. Cool. So this might look different from what you expected. It might be what you expected. Basically, JavaScript says, okay, we have a series of numbers here, and we're going to add all of those together, which is how we get 6. And then it gets to the string part, and it says, okay, you want this output to be a string. And then it does type coercion, and it turns this number into a string, which it just kind of plops onto the front of this existing one here. So that's what type coercion looks like in practice. To show you an example of how variable definitions look in JavaScript, you can write code that looks like, here, let me comment out this part. This, where you're defining a variable y and you're logging that, and then you can change the data type altogether to a string and have that work. So JavaScript is totally capable of doing that. Whereas if I had a language where I was writing like string equals 12, and then I attempted to reassign that to another word, that would break. But JavaScript should just kind of cleanly put that variable into a new type bucket pretty easily, which is useful in some contexts. It also can make it difficult to debug problems when they happen. Cool. So continuing on, quick tip here. I tried to insert some of these to give kind of helpful advice in programming in JavaScript as we go along. So JavaScript can convert numbers to strings, and sometimes that works in a way that you expect, and sometimes it leads to odd behavior. So let's try an example of that. Cool. So in the previous example, we had one that looked like this. So if we run that, it's just going to take the number 5, turn it into a string, and then concatenate it with the character X. But if we do subtraction here instead, it's going to turn into something a little unexpected. So this isn't something that you can cleanly rely upon. In general, if you're looking to create strings that are composed of numbers and strings, it's probably a better idea to explicitly cast the numbers to strings to make sure that you're not relying upon these operators. So concatenation works well, but you can't just like subtract a string from a number. So again, this will work. This one will give you a weird output. So you could do something. I'm going to experiment with this a little. If I cast X to a number, yeah, same thing. It's going to give me not a number. Cool. So be careful when you're doing this. You can use the arithmetic operator to do string concatenation, but that doesn't apply to all kinds of operators. You can't like divide and multiply numbers and strings in JavaScript. So be careful there. And then another tip, try to initialize variables as much as possible. You can create a variable without defining it in JavaScript. And when that happens, it'll be undefined until a value gets assigned. But it's generally considered a good practice to define your variable as whatever the default should be. And if that's undefined, that's okay. So that you don't end up with an undefined that you don't expect somewhere, because that can lead to breaking changes. So as an example, I think I have a REPL here somewhere, but just to show you kind of what this looks like, if I have X like this, oh, I need to do a let here actually. So if I declare X without assigning any value and then I log it, it's going to give me undefined. And that can be okay if you're expecting to get undefined as a possibility and you're accounting for that by doing good type checking. But it can also lead to errors. To try and think of an example, if I did something like this, if I tried to apply a map function, let's see here. And then I run this, it's going to give me an error because X is undefined. So if instead I made this like the empty list or something, then my map won't break. So it's a better practice in general to initialize the variable to whatever you expect it to become later. Like if I'm going to have this be a string, then I would make it the empty string. Cool. So picking back up. So variable declarations, you've probably seen that I've done a couple of different things here. So I want to explain that. The old way of initializing JavaScript variables was by using a var declaration. But with the introduction of ECMAScript 6, the preference is to use what's called let and const. And you're supposed to use let for variables that are going to change and const for variables that you expect to remain constant or not change in the control flow that you're looking at. So let me give you an example of that as well. Kind of shown a couple, but this is how all variables used to be declared in JavaScript, which is nice, and it's not going to throw errors for the most part, but it can also lead to problems. There's not a lot of like error checks built into JavaScript, particularly in its initial form. So people wanted some stricter structures to work with, basically. And let and const allow you to enforce whether or not a variable is going to change. So if I have a variable that let's just say like, let x equal the number 0, and then let's add 1 to x and log what that looks like. Oh yeah, and I need to use a different variable. Cool. So that works fine. It adds 1 as I expected. But if I declare const here, it should complain. Yeah, so I'm attempting to reassign to a constant variable now. And it's going to give me an error. So this can be a useful thing to do if I was writing code, for example, where I expect to have one value be the exact same throughout an entire endpoint or function. And then I start seeing an error like this, that's a signal that I've done something wrong. So it forces you when you're programming to decide what variables should change and which are not going to change at all. And it gives you some error, some type checking around that. Cool. So we talked about ECMAScript a little bit. ESLint is something that's also commonly used if you're coding in JavaScript. It's a static code analysis tool, and it's useful for enforcing certain rules. So a lot of companies have their own flavor of this that they'll use to enforce standards for writing JavaScript, because like I said, it can be a little bit loose. So here's an example. This is from just eslint.org/demo. And if I have code where like this, where I'm creating a variable foo and assigning it to something called bar, it'll give me errors based on some configured rules. So this first one is foo is assigned a value but never used. So if I'm writing code and assigning a variable, I should do something with it, or else I'm just taking up memory for no reason. So it's throwing an error because of that. And then the second one is I'm attempting to assign to something that's not been defined. So there's a lot of different rules that you can enforce. If you go through, you can see like, I can just configure a bunch of options. Like, let me see. You can enforce rules around indentation to enforce consistency there. Quotes. So for example, if you want to have everyone use double quotes throughout your code base, you could apply an ESLint rule for that one. So there's a bunch of different options here, and it's pretty common for most companies to create some version of this so that you have consistency throughout your code base. It makes it a lot easier to review code as an engineer when it's all generally following the same practices. And it's just kind of a good practice to get into as well. Cool. So that's ESLint. ECMAScript is a standardized version of JavaScript. And ECMAScript 6 in particular came out in 2015. And it was a huge new version that had a bunch of new features people were really excited about. Some examples are promises, which are a good way to do asynchronous development in JavaScript. That let and const distinction we talked about, and then some other things as well. So ECMAScript is defined by something called the ECMA Council. ECMA is the European Computer Manufacturers Association. I think that's what it stands for. And basically their job is to create standards for the World Wide Web. So they allow us to use all modern major web browsers and have certain expectations about how the JavaScript is going to look, what certain formats are going to look like, things like that. So it's very useful. And basically, companies that have a vested interest in JavaScript and its continued development will pay a certain fee to sit on the ECMA Council and have voting privileges. So for example, like Facebook and Google all do this. And then they develop together standards for the language. So ECMAScript 6 is right now the latest version. It came out in 2015, and it was really great. It just had a lot of things that people had been asking for about JavaScript for a long time. And that's kind of a pattern with JavaScript in general. You'll see it took off really quickly because it is the main language of the web. And there's kind of this pattern of a lot of people use JavaScript, it grows, they apply it to a brand new context, and then they'll realize like, oh, the language wasn't really designed for this purpose. I wish we had this and this feature. And then eventually ECMAScript will catch up and give them that feature, or there will be some kind of library that you can use to get that on your own. So yeah, we like ECMAScript 6. You'll see it referred to as ES6 as well. Cool. So now we're going to get into actually, oh yeah, we've been talking about this a little bit, but I want to show you a static type checker. So because JavaScript is very loose with how types are defined, a lot of companies use something like Flow or CoffeeScript or TypeScript to enforce stricter standards about how types are defined. So here's an example with what Flow looks like. And if I were to run this in a REPL without Flow, there would be no complaints. But here I'm defining what specific types will look like. So we talked about how in JavaScript, you'll never write code that looks like this. But you can have something like this where you have a function and you're defining the type of the parameter that you're getting. So here X is the parameter that's coming in, and it's going to be a number type. And then you're also defining the type of the output, which is going to be a string. So here it's throwing an error because we want to take in a number and output a string. But right away, it's saying if X is defined, return X. And because X is a number, this breaks the rule here that requires us to return a string. So if I did something like this instead, that would clear up the error. Cool. I think I have a question. Is JavaScript a language that is generally very picky about using semicolons? No, you don't have to use semicolons. Some companies enforce semicolons through a linter, but you don't have to use them, like Choi said. Cool. Yeah, so that is how Flow works. It allows you to enforce certain rules like this, which is pretty handy. This is something we have in my code base, and it's a good signal if I were to see an error like this, that something unexpected is happening and there's some kind of bug that I have to figure out. So it forces you to be like really strict about, okay, I expect this function to take in this type and return this type. And those types can get pretty complicated. Cool. So primitive data types in JavaScript, there are 6. They are string, number, undefined, Boolean, big int, and symbol. And what makes them primitive is that they are not objects in JavaScript, and they do not have their own methods. So a big one is strings. This is one that you'll use very frequently. String is a series of characters. So it could look like hello world. It could also be a series of numbers as a string. So I want to show a couple of examples of that. Cool. So here's a bunch of different strings. These ones are pretty conventional. This one has a single quote, so that's kind of fun. This one has 2 different brackets, and in this one, we are adding a number to a string, which will give us a string. So these ones are pretty basic. Here, I am logging the string, and then I'm also logging its type. This is pretty useful in JavaScript. You can use the type of operator to figure out what a type you're looking at exactly. So to show couple of examples of that. This is the number. This is an empty object. That's kind of how type of works. Cool. So that is strings. You can do some things like grab the length of a string. So the length of A, that's confusing. So hello is 5 characters and then 6 is added on. So it's 5 characters in total. You can concatenate strings like this. And yeah, that is probably the 2 most useful things. Cool. Numbers, also a very important data type in JavaScript. The number is the main numeric type in JavaScript, and it can be both decimal or a whole number. So in some languages, you have a concept of floating point numbers separate from integers. In JavaScript, all of that is encapsulated in the concept of number. So if I run this, these are all of type number. Does anyone have questions? Sometimes I lose the chat, so I want to make sure I'm staying on top of that. Here we go. Okay, cool. No questions. So yeah, so this is probably the most unexpected piece, is that you can have a number that looks like this, because in some languages you'd be required to refer to that as a float. Cool. We'll talk about numbers versus big ints in just a minute. All right, undefined. This is typically used for unassigned variables in JavaScript. So for example, if you just declare let x, it'll be undefined. So let's try that one out. Cool. So if I declare that on its own without defining it, it'll be undefined. And if I make this a const, it'll complain, I think. Yeah, because I can't declare a constant variable without initializing it from the very beginning, but you can do that with let. So another example would be if I have a function like this, and then have no parameters, and it's just going to return. And I'm pulling in x. If I call this function without initializing x, let me delete that, I will get undefined. So that's a pretty common one in JavaScript. Cool. And now I want to say a little note about the difference between undefined and null in JavaScript. And I would say the most confusing thing about this is that undefined is a primitive type and null is not a primitive type, it's an object. And that is a common cause of confusion. And this is from the Professional JavaScript for Web Developers book. It says, you may wonder why the type of operator returns object for a value that is null. This was an error in the original JavaScript implementation that was then copied in ECMAScript. Today, it's rationalized that null is considered a placeholder for an object, even though technically it is a primitive value. So you can kind of rationalize why this is, that null is an object and undefined is primitive, but the reality of it is that it's kind of a mistake in how the language is created from the very beginning. And again, because that's in version 1 of ECMAScript, that's how it's going to be for the future, because it's backwards compatible. Boolean, this is an important data type. So let's show an example here. Cool. So I would declare these as const. So I have x is true and then false, or sorry, yeah, x is true and then y is false. And I'm taking the and of true and false together here. So does anyone have a guess for what z will be? Let me write that out. Anyone got a guess for what will get logged here? XY, yeah, so if these were strings, then that would be the case. I'll give you a hint that Z is going to be a Boolean here. So either true or false. Yeah, so it'll be false. So if I log this out, it'll be false. And then if I were, like if this were to show an example of how this looks with strings, let me just flip these really quick. Because someone, so this one's a little bit more interesting. What'll happen here? Oh, interesting. So this one, it only took Y. Oh yeah, okay. So this one is evaluated a little weirdly. So it's saying, is X true? If so, return Y. That's a little bit of a confusing flow, and I wouldn't actually write code that looks like this because it's hard to read. But yeah, just a fun fact for how that would look with strings. But yeah, if you do true and false, it's taking the and of true and something that's false. And because one of them is false, it'll be false. And that type is a Boolean. Cool. So big int, oh, I think the definition here I wrote is wrong. That is copied over from Boolean. So let me fix that really quick to not be confusing. Sweet. So let's try out what a big int looks like. So number, as I said, is kind of doing double duty. It's allowing you to write a whole number and also floating, it does floating point arithmetic. So we have this other concept in JavaScript called big int that is specifically designed for larger numbers. So you can initialize that in two different ways. You can add an n to the end of a number like this, and that'll give you a big int. You can also create it by using a constructor like this. So I'm going to run this. We have here a big int, a regular number, and then a big int at the end. I'm going to avoid logging too many things. Cool. So the type of this first one is a big int, and also the third one. And something interesting to notice about this number is that it's a regular number, and what I initialized it as doesn't actually match the result that I'm getting here. And that is why we have the concept of big int in JavaScript in the first place. Eventually, if you keep typing a bunch of numbers like this, you'll reach a big enough number that will overflow in JavaScript. And the number data type is not designed to account for that. So in number, the maximum integer that you can use safely is this super long number here. And if I type a number like a that is greater than this number, so this should be true. Yeah, so this a is bigger than the maximum safe number, which is why it's overflowing to the next value. So if I need a number like this, I have to use big int instead. So it's an important thing to think about if you're dealing with really large numbers. Now I'm going to close out of a bunch. Oops, not that one. And close out a bunch of these REPLs here to make things a little bit cleaner. Cool. All right. So the next, this is our final primitive data type, and that is symbol. Symbol is described as it's a unique anonymous value. And I think this is probably the most confusing one of the 6 core primitive data types in JavaScript. To give you an idea of how it works, it can be a number or a string, and you initialize it by using this constructor. And I won't give this away. So I'm initializing a string here, I'm initializing a number, and then I'm initializing a third string here. Cool. And when I log what that looks like, I'll get something that just looks like symbol 1. So if you have in JavaScript, like if I were to have 2 different strings that I construct by doing this, and then if I were to check that they're equal, I'm going to get true. So does anyone have a guess on what's going to happen if I compare the symbol 1 to this third one here, symbol 1, X and Z? Anyone have a guess of whether that'll be true or false? True. Yeah, so you would think that it would be true. This is deliberately tricky because string 123 is equal to string 123. But if we do this with symbols, that'll be false. And if I do even like this, it's going to be false. So yeah, because they are different objects, which is basically the point of this data type in general, is that it allows you to declare multiple symbols, and you could be inputting the same exact value. Like in this case, I'm inputting the number 1 2 different times, and you're still going to get a different result. And I have a question about equals and double equals and triple equals. I'm going to talk about that a little bit later. Sorry, I know it's a little confusing, but that's kind of its own subject. So we'll get into that in a minute. But this should work either way. If I compare them, I get false for both of them. So basically the idea of symbol is that if I were creating like a hash map or something like that, and I needed to have a unique value every single time, and I had a concern that I could somehow get the same input. So like if I were writing a function called get unique value, that's going to take in, say, a number in a string, and I want to return a hash for that. A part of that could be returning a symbol, which will make sure that even if I put in the same exact thing, I will get a different output. So let me comment out all of this so we can see only this one. Cool. So these are different, even though I'm putting in the same exact number. So it's useful in some contexts. To be totally honest with you, I don't use symbol at all in my day-to-day job. And if I were writing a hash function, a good hash should be guaranteed unique. So it's kind of an interesting feature that could be used in some contexts, but don't worry if it's confusing, because odds are that you won't need to use it very much at all. Okay, cool. So now we're going to talk about comparison. Someone asked about double equals versus triple equals. Yeah, that's a great. I was using double equals for one and triple equals for the other. And those are very different in JavaScript. You want to, as a general tip, use triple equals whenever possible. Double equals in JavaScript converts first to matching types before comparing two different values. So if I'm comparing the number 1 and the string 1, if I'm using double equals, it'll say, okay, which data type should I use? And then it'll convert them to the same type and then do the comparison. But triple equals will look at both the type and the actual value and say, okay, these are just different types, and then return that they're not equal. So I'm going to show you an example of what this looks like. Double equals comes from the first version of ECMAScript again, and triple equals, which was introduced, I think, in the 3rd version of ECMAScript. So this is another example of one of those things where it works slightly differently because JavaScript has to maintain backwards compatibility across every single version. Cool. All right. So here I'm going to compare 0 to the empty string 1 to the number 1, and then the number 1 to true. So I want to show you. Let's do this. I'm going to run what this looks like in triple equals. And none of these are equal, which probably makes sense because, as we know, 0 is not equal to the empty string. So that makes sense logically. So this one returns false, false, and false. If we use double equals, does anyone want to hazard a guess for, let's say, this first one? What will this return? Yeah, true. So maybe I've given away the trick here a little bit, but yeah, this is going to return true. So just to show you, yeah. And the reason why is that JavaScript is saying, okay, these are two different types. I have to convert them to the same type to make a comparison. So it converts, I think in this case, both of them to Booleans, and 0 is equal to false as a Boolean, And then the empty string is also going to be false. So if you compare those after conversion, they will be equal. And then similarly, if you convert the number 1 to a Boolean and the string 1 to a Boolean, you'll get the same thing. But it's pretty confusing because, like, logically, just looking at this doesn't make a ton of sense. The number 0 is not equal to the empty string in any language. So this is one of those frustrating pieces of JavaScript that I was talking about before, where sometimes it can be kind of unclear exactly what's going on. So yeah, my best advice is to use triple equals when possible, because it's going to take both the type and the value into account. Great. So we talked about history a little bit. We talked about data types, which was the longest section today, I think. And next, we're going to talk about arrays and objects. So I guess, first of all, we're going to start out by talking about objects. Objects are not primitive, and in general, they're used to store more complex forms of data than the primitive data types that we talked about before. The most basic form of an object that you'll see looks kind of like what we would call a dictionary or a map in some languages, where you have a key and a value. So in this example, my key is 1, my value is 2. Here you have the key is name, and my name is Amanda, so the value is Amanda, and the key is location, and the value is SF. So let's try a couple examples of these. It's a pretty extensible data type that you'll probably end up using a lot, particularly like in programming interviews. So here we have a dictionary. We have Sarah, the age is 12, and the food, let's say this is her favorite food, is undefined. So you can have all different kinds of data types mixed in here for the key and the value. And if I overwrite one of these types, that'll get overwritten in the object. So let's say I overwrite the name to be Amanda. Then when I log it, the name will be Amanda. And the type here is an object. So just to kind of show what's possible here, this data type works really well for a lot of different things. So to show an example of what this might look like at a company that has, so for example, where I work, we need to store the concept of a company, and then we also need to store the concept of an office. So a company has attributes like name, for example. So let's call this Luke's Local, which is the name of my local grocery store. And then let's say that we want to store the number of employees for some reason. Maybe the year founded. And we could actually have like a date here as well. We're not going to get into the date type today, but we could do something like that. Oh, and I'm making this as an array, which is totally a mistake. Cool. We could have something like office, which could be its own nested object. So let's say that an office has something called a location, which will be just the string here. What else can we do? We could have one of the fields be undefined. So let's say like revenue, we don't know the revenue, so that's going to be undefined. You can do a ton of different stuff basically with objects, and they're often used to represent nested data like this. You could also have here like a list of employees. So let's say I'm going to have a list of employees, and each of those employees is going to be an object. So you get the idea. And if I wanted to get the employees for this company, I could do something like this. Cool. So pretty extensible. You could store a whole bunch of data, a whole bunch of types here. And yeah, it goes a long way. Cool. And if you have questions at any point, drop them in the chat and we can stop and talk whenever. Arrays are a form of object. So underneath the hood, an array in JavaScript is an object. And basically it's just used to store a bunch of a particular thing. So you can have an array of numbers, you can have an array of strings, you can also have an array of mixed data types. So here we have a regular vanilla array of numbers. Here we've got a list of strings. I use array and list interchangeably. And then this one has some mixed data types. So that's also a possibility. And if you log the type of all of these, it'll be object, because underneath the hood, these arrays are objects in JavaScript. And again, you can have an array nested within an object. And I think you can also have, yeah, you can have a list of objects. So if we took, do I have my company from before? Yeah, let's just copy this. And we can maybe create another company, and then I can nest these like this. So you'll probably frequently interact with data entities like this, where you have lists of objects, and then within objects you have lists, and then sometimes within a list of objects you'll have an object that'll have a list of objects. It just can continue going either way. So you can do a lot just with those two data types. They're both very important. Cool. So we talked about arrays and objects. Now let's talk a little bit about control flow. So control flow is the order that statements are executed. So for example, different block statements are forms of control flow. And probably the most well-known ones are if and for and while. So I'm going to show some examples of that. Actually, I think this is, okay, well, I think I overwrote the example that I was going to do, but we'll just go through and show. Oh yeah, okay, so this is an if statement. Pretty basic. If you have this function and you pass in x, and if x is defined, we're going to print x and then return. And if not, we'll print the else statement. So I'm not defining x, so else will get executed. You also sometimes see this written this way. And which one is preferable kind of depends on where you work and also the context. In a setting like this, where it's a pretty basic function and it's obvious that it'll eventually just fall through to this do else condition after the if block gets passed, you don't have to explicitly write else in this example. Although if you didn't have a return statement, it would actually execute both of these. So depending on the context, you might, for clarity, want to write the else statement here, or just leave it off if it's obvious that it'll fall through to the else condition. And you can also have these. So let's make it a little more interesting. If x equals 1, and then if it equals 2, we'll do this. And then it's neither of those, so we should fall through to the else condition. Cool. So that is if else. I'm going to leave this example. No, I'll get rid of it. Now let's do a for loop. So for loops are pretty useful. Let me see if I separated this out. Yeah, so I have another REPL for this one. A for loop is used whenever you want to run some block of code repeatedly. Either that or the while loop will be used. So here's a pretty basic for loop. We're starting from the number 0, and then we want to continue printing x as long as x is less than 10. And at every single iteration of the for loop, we're going to print x. So it looks like this. And if I wanted it to go all the way up to 10, we would do less than or equal to here. Cool. And then this one is starting from the number 10. And while y is greater than or equal to 0, it's going to print y, and then we're going to subtract 1 every time. Cool, so you can see I'm counting all the way up to 10 with this first loop and then counting all the way back down here. I could also do this by 2, so I can change the step that I'm using here. And then I go from 10 to 8 to 6 and so on. And then I can also use a for loop if I want to let's say I want to build some text here. So I'm initializing it to the empty string, and then I want to add a little dash every single time. So I could do something that looks like this, where it's adding a new dash every time it prints out my string. Cool, so pretty useful one. While statements are another form of a for loop. And a while statement will typically look like this. So if you wanted to do the same thing that we were doing before, where you have x initialized 0 and you want to continue incrementing it until you reach 10, you would write a while loop that looks like this. So while x is less than 10, you're going to log x and then increment it every single time. And a common question here is when to use a while loop and when to use a for loop. And a common misconception is that you cannot use a for loop to evaluate an expression. So for example, you'll commonly see things like this. So let's say like, this is true. I'll make it a let. And while this is true, I want to keep logging, let's call this y, and then incrementing y. And when y gets to the number 3, I'm going to break out of this loop. So I'm going to make this is true equal to false. So let's see if this works. Cool. Cool. So as soon as I reach the number 3, I break out of my while loop. And sometimes people think that you can't write this kind of logic in a for loop, but you can. So I can have the same thing. Let's say we'll make this expression, this is true. And then while this is for the duration of this being true, let's do the same thing. And I think you have to write, let's see if this works or not. Cool. Y is not defined. Cool. Assignment to const variable. Yeah, this should have been a let. Yeah, so this works in the exact same way. The main difference, though, is that you honestly will rarely see code like this executed with a for loop. Just in terms of convention, while loops are more commonly used to have something like this, where you're checking for a condition, whereas for loops are typically used in the pattern that we saw before, where you have a number that's being incremented one by one, for example. But just a fun fact that you can actually write anything that you can write in a for loop in a while loop and vice versa. It's kind of just about the semantics of what's cleaner to read. Cool. So next I want to talk about block statements. That's another form of control flow. A block statement is something like break, which is used to break out of a loop as it's going. So the way that it'll look is you'll have some conditional code that's acting upon a condition and doing something if it's true and something if it's false. And if you want to break out of that for one iteration, you'll use the break statement. So let's try an example of that. All right, cool. So we have a for loop that looks pretty similar to some of the ones that we saw before. But this time, if x becomes equal to 3, we're going to break out of the loop. Cool. So once x is equal to 3, I break out of the loop. And that's all there is to it. So this can be useful if you want to have a loop, but if something becomes true, immediately stop the loop. And the counterpart to that is what's called a continue statement, which is used if you want to break out of a loop, but only do it once. So let's say that I want to print the numbers 0 through 10, but I don't want to print the number 3. So I'm just going to add a continue statement here. Let me add that log before to show you when the loop is done executing. Cool. So you can see here we're going from 0 to 1 to 2, and then we skip the number 3 and then go right back to 4. Whereas if we made this a break statement, it would just end the for loop altogether. So continue is a way of just skipping that single iteration, which can be useful sometimes. All right. Switch statements. This one is probably the least common of the ones I've talked about so far. It's used if you have a particular value that can be one of several values, and depending on which one you're looking at, you want to do something different. So you'll often see in this context, let's say that I have a number and I want to return something based on what that number is. Or like an example where we use this in my code base is with error types. If you receive this particular thing, you return this error type. So the way that it looks is you'll have a switch statement with your variable, and then you'll go through and enumerate different cases for what that variable can look like. So if the variable is 1, you're going to print case 1. If it's 2, you're going to print case 2. And then if it's neither of those, you're going to print default. And an important piece of writing these is the break statement that we talked about before. So if I eliminate this break statement, let's do this, and put in the number 1, does anyone have a guess of what's going to log here? If I run this function with the number 1, which one of these statements will it execute? Case 1, yeah. Yeah, thank you, Shreya. So it is going to execute case 1, but because I've removed these break statements, it's also going to execute the default. Oh, and actually in this case, it's also going to hit case 2 because I didn't break out of my loop. So what you want to do is that as soon as you hit this statement, break out of the loop altogether, or else it won't really work. So now, yeah, in this case, it's going to execute case 1, like we talked about, and then 2. And then if I have like something else, it'll go to the default. Cool. So again, this format's not super common, but it is useful if you have some logic where it's like, oh, if the variable is this, I want this. If it's this, I want this, where you can cleanly match up the different cases to your output. Cool. So now I'm going to talk about functions, which is going to involve taking some of the stuff that we've learned so far and putting it together. It's also probably the most exciting and applicable part of what we're going to talk about today. So functions, in short, are a block of code designed to perform one task. So a quick example function, it's not formatted well at all on this slide, but you could have an example function that takes in parameters x and y and then returns the sum of x and y. So let's try out some functions. All right, cool. So there's a lot here, but I'm going to go through these one by one. I'll just kind of comment out the rest of this for now. So the most basic form of a function, I would say, is something that looks like this in JavaScript. You have your function, you have its name, and then you have parameters, and then your function is doing something. In this case, it's returning the sum of x and y. So if we were to run this function, we're going to take the sum of 1 and 2, which will be 3. Confusing part is that in JavaScript, there are many ways to write a function. So you can have this, which is probably the most common example you'll see. You can also have something called an anonymous function, where you're assigning a variable to a function without a name. So in this case, I'm instantiating it by calling the variable that I have assigned to this function. And it's taking 2 times 3, which is 6. What the functions are actually doing is not super important here. I just want to show some examples of different ways that you can write this out. So we have here an anonymous function without a name, and it's also an arrow function using the arrow syntax, whereas here we're just using the curly brackets without an arrow. So a named function is something like this, where you can assign a variable. You can write it like this up above with no assignment, or you can assign a variable to the named function itself. So 3 different ways. Both of these, example and example 3, are named. And in the second and third one, I'm assigning a variable to the function I'm declaring. And then a fourth way that you'll probably see functions used is within a map or some other kind of function within JavaScript that creates an arrow function to execute several times. So let me comment out these first ones. And here I have an array of 4 numbers, and then for every single number in the array, I'm going to use this for each to go through and do something. So in this case, all I'm doing is logging every single number. And it may seem surprising, but this piece right here is actually a function. It's a function that's being executed within a for each. So actually, I think it has some useful documentation here, it looks like. Let me see. Yeah, so you're using what's called a callback function for every single element in the array. So I'm taking my for each loop and applying that callback to every element that I have here. And map works the same way. There's some other ones like reduce and things like that that you'll probably get into later on as you learn more JavaScript. But yeah, that's the basics of functions and how they're written. Scope is an important piece of how we talk about functions. There are 2 different kinds of scope. Local scope is the scope that applies within a function exclusively, and global scope is any variable that can be accessed throughout a file, not just within a particular function. So as an example here, I have X defined at the global level, and I also have it defined at the local level. So if I log, let's say, this one here, does anyone have a guess of what X would be in this case? Oh, I just ran it actually, so that's kind of a spoiler. But yeah, X in this case is going to be the number 1 because I've defined it here. But if I run this function here, does anyone have a guess of what X will be in that case? 2, yeah, thank you. So in this case, X will be the number 2 because the local scope that I've defined here is going to overwrite this higher scope. And if I were to comment this out, then there's no local scope, so it's going to reach into the global scope and grab that. Take a drink quickly. So this can get pretty confusing. And my best tip is to avoid global scope as much as possible. You want, in general, to localize scope as much as you can because it's going to be a lot more obvious to someone reading your code where exactly that variable is defined. So like if you look at this example, if I'm reviewing this code, it's just confusing to me to see like, okay, X is here, it's also here. So this is a bad pattern. If I were actually writing this code, I would name it something different so that there's no chance of getting mixed up between those 2 values. But global scope is useful, especially if you have something that's going to be applied to multiple functions throughout a file. Like, for example, if I need an API key in a bunch of different functions, you might define that at the global level. So it is useful, but in general, you want to try to localize as much as possible. Great. So we've talked about everything that we had on the agenda, but I want to get into doing some demos here. Great. So now we're going to go through some problems to try and practice some of the things that we talked about. Cool. So the first one is write a function that counts the digits in a number. So given a number that looks like this, I guess this would be 12,345. I want to count the number of digits, which is 1, 2, 3. Oh, it's actually 5 digits here. So I wrote that wrong. And I have this function skeleton written out where I'm taking in X, which is going to be a string. So I'm going to start out by just logging X and calling it here. And I'm going to write it in the same format. We're not returning anything yet. So it's just logging the numbers so far. Cool. So when you look at this problem, because you're using it as a number, it's difficult to figure out exactly how many digits are here. And there's a way to do this mathematically, but another way that you can do it is by converting this number to a string. So if I do something like this, let's log what that looks like. All right, cool. So now it's probably more clear to just do type of. So you can see that it did work and it is a string. So now that we have access to this number as a string, does anyone have an idea of what we could use to get the number of digits within that string? It's something that I mentioned like very briefly early on, but it's okay if people don't remember it. Yeah, exactly. We're going to use length now. So pretty easy. Just do this. Oh, and so now we can see that there are 5 digits within this number. So it's a way of using the different types. Cool. So now for problem 2, we want to use a for loop to calculate the squares of numbers 1 through 5. So let me clear this out and add this at the top here. Cool. So I'm going to write a function called getSquares. And I don't need any input here. And it says in the problem statement that I want to go through numbers 1 through 5. So let me do this. And does anyone have a guess of what we're going to do to each of those numbers within that function? Call it down here. So if we just wanted to log them, it would look like this. It says oops. Yeah, multiply the input by itself. Thank you, Isabel. So now I'm just logging the number here. So I'm gonna get 1, 2, 3, 4, 5, 4, 5. And if I wanted to get the square, I can just do that. Cool, pretty easy. Problem 3, we're gonna write a function that lists the different properties of an object. So slightly more advanced here. Given an object where I have different properties that look like this and this, if I do something like this, I want to get all of the key names, as they're sometimes called, here. Cool. So this one relies upon something that I haven't really talked about yet. So there's a way to get the different keys from an object in JavaScript. If I go like this, I think it's just like this. Let's see if that does it. This is complaining. Oh, I think I might need to do object.keys. Invalid or, so it's giving me an unexpected token. I think this might be because I'm using, yeah, I have this issue all the time with quotes, which is pretty frustrating on a Mac. Cool. So this is what keys looks like. So I can get the names of my keys, name and age here. And this is asking me to list the properties here. So I'm going to go through, you can do values actually. Let's see. Yeah, okay, cool. And then once I have those, I can just take each one and log it. Cool. Easy enough once you know how to access the keys. And this one's pretty similar, write a function that counts the true values in an object. So when it's instantiated, when we call it like this, it should return the number 2. So the output here is going to be 2. So let me add my example here. So we already talked about how to get the values. In this case, I'm going to need both keys and values. And do this, name it correctly. And then I'm going to log my result at the end. So I'm going to get each of the keys and I'm going to loop through each key and look at the value. So for my dictionary, oh, this is confusing. Yeah, let me add true dictionary will be the name here. And then for each of those keys, I'm going to access the value like this. Let's make sure that that looks right. Cool, so we're getting true, true, false. And then I want to count those. So let's just say true count. And every time we see a value that is true, I'm going to increment it. And then at the end, I'll return that. So if I've done this correctly, it should be the number 2. And yeah, it should be a not constant variable. Cool. Yeah, so there are 2 trues in this object. Cool. And then one that I briefly wanted to show, use a map to double every item in an array. So this one's slightly more tricky. I'm going to call this, let's put this array in, and I'll call this array doubler. It's going to take in this array. Let me erase this. Cool. So if we use something like what we had before, we could do something like this. Let's call this list L, and just go through every item in the list and then double it. But when we do that, let's log my list at the end. Let's see what happens. It's going to be the exact same as it was before. And that's because we're not actually changing anything about the list by adjusting the value of X in this context. In order to actually overwrite what's in the list, we need the index itself. So you can do that with map by doing this. So X is going to be the value. Let me make this clear. And then I is going to be the index. So we're going to double the value. And let's make sure that looks right. Sometimes it takes a little while to refresh. Cool. So it's doubling, but it's still not changing the original array. And then in order to actually change the array, we need to overwrite what exists at every index like this. And then you can get the doubled version like that. So those are like kind of easy level function problems in JavaScript. But I also wanted to show you what this might look like in the context of a web application where you have like some HTML and CSS alongside JavaScript, because I know that you've been working on HTML and CSS as well. So let's say that I want to write a really basic calculator where I'm going to perform the addition of 2 different numbers and then get a value. So I have some boilerplate written here, a couple of numbers, and then a result. And I have this function here that's going to get triggered every single time I click the add button. So as an example, I can look at the console here in CodePen, and every time I click add, that's getting triggered, which is helpful. So this requires me to know how to do a few things that will rely upon manipulating the DOM. So I'm going to show you how to do some of those. The first thing that I need to do is access both of these numbers that I'm going to want to add. So let's take the number A, and I'm going to use this syntax called document.getElement by ID, and I'm going to grab this number. And if I log what that looks like, should log when I hit add. Here, let me change this up a little so you can see a little bit more of the console. And I'm gonna move this. I can clear it here. Cool. So when I hit add, I can see I'm getting the like HTML here, but what I actually want is the value. So I want to get this 1. So I'll do that by getting the value here. And then when I hit add, I have to actually add a number there. It'll give me the number itself. So I'm going to do that for A and B. And this should give me, and then I'll be able to calculate the sum of A and B. So I'm going to log what that looks like. Cool. So let me save that and clear my console. And then if I put in 1 and 2, okay, cool. So this is coming back to one of the data type issues we talked about before. I'm putting in the number 1 and I'm putting in the number 2 and I'm getting 12, which doesn't seem to make a ton of sense. Does anyone have an idea of why that is, or what we would do to fix that? Assuming we want to get a normal sum of 2 numbers, like 3 for 1 and 2. Yeah, it's concatenated as a string. Thank you, Isabel. So in order to fix this, I need to cast both of these to numbers explicitly. And then if I add these in, let me clear my console again. I'm going to get 3, which is what I expect. And then the final piece of this puzzle is actually changing the value itself. So I want to get my result here, which is called a result. And then I'm going to set, I think, the inner HTML to be the result of my 2 numbers being added up. So let's try that. Clear my console again. Cool. So now you can see that both of these numbers are adding up, and that's being displayed on the web page. So this is a basic example of how this might look in an actual website where you have some JavaScript that's interacting with CSS and HTML on the web page itself. So playing with CodePen is a fun way to do that because you can just write this in your browser and be able to execute it right away. And people do some really cool stuff with CodePen. And you can also share them with other people and have them mess with them. So I'm going to send this as an example. If anyone wants to play around with CodePen, you can fork and kind of create your own based off of existing ones. And that can be like a fun project to add to your resume or your website if you have one of those too. Cool. So that was a quick demo. As a brief review, practice writing functions as much as you can. I learned by doing things. So what works well for me is to experiment with the language when I'm not sure how something works. So often when I'm coding in my day-to-day job, I'll pull up a REPL, and if I'm not sure like what syntax to use, I'll just try it out there to see if I can figure it out that way. But use the learning style that works for you. Some people learn by doing, like I do. Some people learn by reading. Some people learn by listening. And knowing that is super helpful throughout your career, basically, if you can be sure of that. So that's all. Does anyone have any questions about what we talked about, or I guess software engineering, anything like that? Oh yeah, and I wanted to share some resources. REPL. Oh yeah, I should have put CodePen up here too. CodePen is just codepen.io, or you can Google it. Javascript.info is the great like open source tutorial of JavaScript. And then the JavaScript guide that's done by W3C is really good as well. Cool. Quick question. If we wanted to use JavaScript for IDE, for app development, which IDE should we use? That's a pretty controversial question. That depends a little bit on your preferences. And to be honest, I'm not super particular about IDEs. Yeah, Xcode works well. I use Atom day to day, but there's tons of different options. If I were you, I would experiment and see like which ones you like best. Sometimes it also depends on if your school will give you access to one, or yeah.
And just thank you so much. But before everyone leaves, I do want to quickly recap some things. So definitely bookmark the student portal for the two forms that you have to fill out by next week, early next week. And also, there will be no virtual event next week because of Thanksgiving break. So please relax, enjoy time with your family. And then lastly, let me just put some links in the chat. Lastly, you can request for a mentor at any point. You don't need to have your idea ready, or like if you don't know if you want to do an app or a website or whatever, that's totally fine. Like that's what the mentor is for. So at any point, once you have a team, then you can get a mentor. Don't worry about anything else. You're good.